Today we are going to learn about Java Intermediate generics. Before moving in the depth, we should know what Java generics mean. So let's see what it means. Java generics are a language feature that allows for the definition and use of generic types and methods. Generic types are instantiated to form parameterized types by providing actual type arguments that replace the formal type parameters. The second question should be, why use generic? Generic code helps to save time and effort in terms of avoiding redundancy and creating more reusable and more general API. Generic helps to enable the type parameter when defining classes, interfaces, and methods. Type parameter provides a way to reuse the same code with different inputs. Now let's see the advantage of using generic code over the non-generic code. That is number 1. Stronger type checks at compile time. In this, the compiler checks the generic code and issues errors if the code violates type safety. It also fixes compile time error rather than waiting for runtime error, which is more difficult to find. In order to get a clear idea, we are going to try some examples of a simple Java program to display that using non-generics can cause runtime exceptions, and we are going to do it on NetBeans. To create an array list that stores the name of the employee, and if by mistake programmer adds an integer object instead of a string, the compiler allows it. But when this data is retrieved from ArrayList, it causes problems at runtime for non-generic ArrayList. In the case of generic code, it would take only string objects and through compile time error in any other case. We will see a simple example of using generics which converts runtime exceptions into compile time errors which save time and effort. Number 2. Elimination of casts. Let's see the difference between non-generic using casting versus generic code not using casting. In non-generic code, they use casting because for every retrieval, it needs to be cast to string for the use, which makes it a long process and time-consuming. In generic code, they don't use casting as they already mention the type parameter at the beginning, making it more clear to the users. So casting is not needed. Let's see some more difference between generic and non-generic code. The basic difference between non-generic code and generic code is in terms of syntax, type safety, typecasting, and compile time checking. Number 3. The last point is enabling programmers to implement generic algorithms. By using generics, programmers can implement generic algorithms that work on collections of different types, can be customized, and are type-safe and easier to read. We also need to know about the type parameter naming conventions. By convention, type parameter names are single, uppercase letters. This stands in sharp contrast to the variable naming conventions that we already know about. Without this convention, it would be difficult to tell the difference between a type variable and an ordinary class or interface name. This naming convention should be remembered. Moving on with the raw types. A raw type is the name of a generic class or interface without any type of argument. For example, given the generic box class, in the following example, capital T represents the type. And the type parameter is mentioned in angular brackets known as diamond. Generic methods. Generic methods are methods that introduce their own type parameters. This is similar to declaring a generic type, but the type parameter's scope is limited to the method where it is declared. Static and non-static generic methods are allowed, as well as generic class constructors. Restrictions on generics. To use Java generics effectively, we must consider the following restrictions and work according to it. The restriction on generics are, number 1. It cannot instantiate generic types with primitive types, number 2. It cannot create instances of type parameters, number 3. It cannot declare static fields whose types are type parameters, number 4. It cannot use casts or instance of with parameterized types, number 5. It cannot create arrays of parameterized types, number 6. It cannot create, catch, or throw objects of parameterized types, and lastly number 7. It cannot overload a method where the formal parameter types of each overload erase to the same raw type. Thank you all for watching the video, and I hope this basic video has helped you in some ways. See you next time.